Okay, so here's task 5. Previously in task 4, I showed you how to balance equations using models and drawing them. You can certainly continue to do that, but I'm going to show you a couple of mathematic ways as well. The first one I'm going to show you is a way that you may have learned it as a freshman if you had Miss Baker. So let me go over that first. I'm going to do the first 5 with you. Okay, so let me show you this way real quick with number 1. So you want to find your arrow and draw a line under it to separate the sides. This way is kind of like the drawing models, but without the different colors. We're just going to use the element symbols. So H2, we would write that out as HH. O2, we would write that out as OO. H2O, there's 2 H's and 1 O. So you can see it's very similar to drawing the models, but without the different colors. So looking at both sides, we need more O's on the right. So we cannot just draw an O, we have to draw the whole thing, the whole molecule that has O in it. So now I've got 2 H2O's on that side, but that messed up my number of hydrogens. They're not balanced anymore, so I need more of these. And again, I can't just draw individual H's. I have to draw the whole molecule, so you can use your copy and paste tool. And then to balance them, I've got 1, 2 molecules, so it's going to be a 2 for the coefficient. For the O2, it's just 1. You can leave that blank, or if you really need to put an answer in there, you can put a 1. And then for the H2Os, there are 2 of them, so a 2 in the blank. So to balance this equation would be 2, 1, 2 for the coefficients. So that's one way to balance. Another way is to do more of a mathematical approach, and it's a little bit more in your head. But again, feel free to use any of these methods so far if they've worked for you. So this is the one that I typically do. So underneath the arrow, I'm going to list all of the elements that are in the equation instead of drawing an arrow. And then to the left of them, I'm going to put how many appear in the reactant side. So there's 1 magnesium and there's 2 oxygen in the reactant side. And in the product side, there's 1 magnesium and 1 oxygen. So this is like that atom inventory we were doing before. So what I can do now is I can see that the oxygen here is not balanced. There's not enough in the products. So if I multiply that one by 2, if I put a 2 here in the coefficient, remember that changes both of these things. Okay, so that's going to change this to a 2 and this to a 2. We're multiplying. So when you put in that coefficient, remember you are multiplying. Okay, so my oxygen is now good, but my magnesium is not. So I need to put a 2 over here to multiply that by 2. And that time it just multiplies magnesium because that's the only element present in that substance for that coefficient. And so now everything is balanced. And you can put a 1 there if you need to in front of oxygen. So 2, 1, 2, again, same coefficients for 1 and 2. That's kind of funny. 2, 1, 2 for that one as well. So those are the 2 methods. So let's keep going. Let's do a few more together here. There's a few tricks and things like that to look out for. So I want to keep showing you a few more. So number 3, we've got calcium plus water gives us calcium hydroxide and hydrogen gas. So again, if we do it the way we were just doing it on number 2, we're going to have calcium, hydrogen, and oxygen, and you list those right under the arrow. So there's 1 calcium, 2 hydrogen, 1 oxygen. On the reactant side, for the products, there's 1 calcium. Be careful with hydrogen because hydrogen is in 2 different places and it's separated by a plus sign. So what I like to do is I don't add them together initially. I write them down separately, and then I add them together. And I'll explain why I do that here in a second. But there are 2 hydrogen in the first substance plus 2 hydrogen in the second substance, and that gives me 4 hydrogens total. And oxygen in the products, there are 2. Again, because of the subscript, it's in parentheses, so it goes to both of those. Okay, so you can see that the hydrogen is not balanced, so there's 2 and there's 4, and the oxygen is not balanced, there's 1 and there's 2. Now, because hydrogen is in 2 different places, we'll worry about that last. Let's do the oxygen first. So I need to multiply whatever is in oxygen by 2 on the reactant side. So that's going to be water. So I'm going to multiply water by 2. Okay, and that is going to change both of the hydrogen and the water in the reactant side. So that's going to give me 4 hydrogen, and that's going to give me 2 water. Oh, look at that. Everything's balanced. So all you needed was a 2 in front of water for this equation. Again, if you want to put in 1s in your blanks, you can, but you don't have to. And when we start writing out the equations and balancing them, writing out the whole equation, if you put a 1, it's actually not, you don't put 1s. So, but if there's a blank, you can put a 1 for these. So real quick, let me just explain why I did this here separately. If you did put a, let's say, for example, we had to put a 2 here. Now, that's not right, but let's just say, for example, if we did that, that would only change part of the hydrogen in the product side. That would only change this part. So that would make this a 4, okay? And I didn't multiply the whole thing by 2. I just multiplied part of it by 2. And that would change this to 2 plus 4 would now be 6. Okay, so I like to keep them separate just because that way I don't make a mistake when I'm doing my math down below. Okay, so you can erase all that stuff. Okay, oopsies. Okay, there we go. All right, number 4. Let me go over a special trick on number 4. Number 4 has a polyatomic ion that is on the same, it's the same in both the reactants and the products. It stays together, it doesn't split apart. So for this one, when we list our elements underneath of here, oops, that's a U there. Okay, and then we're going to list mercury. And instead of listing nitrogen and oxygen separately, we're going to keep it together as nitrate, since it stays together. Okay, so there's 1 copper, 1 mercury, and this nitrate does not have any parentheses around it. So there's only 1 nitrate. The 3 is already accounted for, right? The 3 is already there and there. So there's only 1 nitrate ion. Okay. And on the right side, there's 1 copper, 1 mercury, but this time there are 2 nitrates. 2 nitrates. Okay. So to balance this equation, we're going to need to multiply this nitrate by 2. So we're going to put a 2 in the coefficients, but that also changes mercury. So remember, when you pay attention to when you add a coefficient, it has to change everything in the molecule after it. So this will be a 2, and this will be a 2. Okay? And then go back and double check, make sure nothing else is messed up. Well, actually something is. Mercury here, it's now a 2 in the reactant, so we need this to be a 2. So we're going to multiply that by 2. So that will change, and now everything is balanced. Okay? All right, and I'll do one more with you. Let's do 5 together. So it's got carbon, hydrogen, and oxygen. So there are 3, 8, and 2 in the reactants. And in the products, there's 1, 2, and oxygen's in 2 places separated by a plus sign, so be careful. 2 plus 1 is 3. I left lots of space there to fix my math when I need to. Okay, as you can see in this equation, nothing is balanced. Couple of hints for this one. Do oxygen last, because it's by itself here in the reactants. And it's in 2 places in the product, so it'll make it easier if you do it last. With these kinds of ones, I like to start with carbon. This is a very common equation type that you'll see, where there's some kind of carbon compound plus water gives you carbon dioxide and, plus oxygen gives you carbon dioxide and water. This is a special kind of reaction called a combustion reaction. So this is usually some kind of fuel. But you'll see these kinds of reactions pop up every now and again. This is a very common reaction type. So when you're doing these, I like to start with the carbon. So if I do that, I need to multiply this side by 3. Let me change my color here. So that's going to change this carbon to a 3. But it also changes this part of the oxygen. 3 times 2 is 6. So now that changes my oxygen to 6 plus 1 is 7. Okay. Now let's fix the hydrogen. So hydrogen, there's 8 here, only 2 here. So to make the product side the same as the reactants, I need to multiply the water by 4. Okay. So that will change this to 8, but it also changes part of the water, this part of the water, times 4. So that's 4 times 1 is 4. If I add these two numbers together again, 6 plus 4, now I have 10 total oxygens. Okay, so 10 total oxygens. I've got, these are matching, these are matching. So now all I have to do is fix the oxygen. So how can I make 10 into, or how can I make 2 into 10? I need to multiply it by 5. So if I put a 5 there, that changes that to 10. 5 times 2 is 10. And now everything is balanced. Okay, so good luck with the rest of this worksheet. We can go over it tomorrow. Hopefully I'm back. And just be careful on number 11. 11 is a bit of a challenge. Remember those tips and tricks I told you about. If polyatomics stay together, just leave them together. When you are balancing, there's another one of those combustion reactions. Here, polyatomics, again, hydroxide stays together, so you can keep it together. 20, you can't do that because hydroxide is not, doesn't stay together. But if you see that the polyatomics stay together, like on 13, they all stay together. So don't separate the oxygens, leave them in their polyatomics. So hydroxide and hydroxide, sulfite and sulfite, leave them together. 12, you can't do that because phosphate is not in the reactants. So you can only do that if the polyatomic stays together in the reactants and the products, okay? So you can use whichever method you like. If you liked this method that we did on number 1, you can continue to do it like that. If you liked the drawing that we did on previously, you can do that way. Or if you like the mathematic way, you can do it that way. Whatever works for you. We can talk about this tomorrow. Do your